All right, another new chapter, chapter 10. So in this chapter, we are looking at means and proportions with two populations. So basically in this chapter, we are just building upon what we learned about in chapter 9. So in chapter 9, we were looking at the null hypothesis significance testing and applying that for when we had one population. Now in chapter 10, we're doing the same process. We're still using the null hypothesis significance testing, but this time we have two populations, so we're comparing two different populations. So maybe male and females, or sales in region 1 and sales in region 2, right? So we're comparing two populations now instead of just having one population. So again, the process is the same. We state our hypotheses, we determine alpha, we calculate the test statistic, the p-value, and then we make a decision on whether to reject the null or not. Typically the null hypothesis, remember, it basically says that there's no difference. So in this case, when we have two populations, we're basically saying that there's no difference between the two populations. So that is, like if we're looking at means, for example, the difference between the two means of the population is 0. So it looks like this. This would be the null, that the difference, right, is 0. This is the case for a two-tailed test. However, we can have a one-tailed test just like we did in chapter 9, where we had the greater than or less than, that type of thing. That's fine too. There still are some examples in the textbook that use this that we'll go over. Because we're going to be using Excel heavily in this chapter, the output gives us results for both one and two-tailed tests. A lot of the software, though, sets it up so that the default is a two-tailed test. The reason for that is it's a little bit more conservative. So what happens is you are less likely to commit a type 1 error. So basically what that means is so a type 1 error is when you reject the null when you shouldn't have. So basically with a two-tailed test, it's a little bit more conservative, so you're less likely for that to happen, where you say, oh, we rejected the null, and that's less likely to happen when you have a two-tailed test. So just a little conversation about that, but we'll look at that when we do our examples. And then last thing, you need to differentiate between the independent and matched samples. So independent samples are not related, whereas matched samples are. That is, they're paired or they're related in some way in both conditions. So this is important because typically we assume the observations are independent. So if we're looking at people, for example, and they're asking for their opinions, we assume that they're independent. But with a matched sample, for example, maybe you have the person 1, for example, using some technique, and then you ask them to do something else using a different technique, right? And you want to compare the two techniques overall. Well, that same person is doing both techniques, so they have that commonality. There's that commonality there, so we have to account for that basically. So basically what I'm trying to say here is that when you're using when you're comparing two populations, you need to know if those are independent or if they are matched, because that's just going to affect the analytical tool that you decide to use. So that's it in a nutshell of the overall part of the chapter. A lot of the concepts we've already talked about. We've talked about, you know, the null hypothesis significance testing, test statistics, p-values, one and two-tailed tests. So everything that we learned about in chapter 9, we're carrying over into this chapter. So you've already learned about and hopefully understand those concepts. So in this chapter, we're not going to focus too much on the formulas and those concepts. Instead, we're going to focus on the application. So I'm going to show you a lot of the problems and how to do them in Excel. You already know really how to do a lot of these by hand, because it's the same concepts that we've already learned about. So in the real world, you're not going to do these analyses by hand. You're going to use software. So I want to focus on that application and have you really start using Excel. So that's what most of the rest of the videos are going to focus on, how to do these problems in Excel. So we're going to focus on the first 3. So a z-test for two population means with a standard deviation known for independent samples, right? So when we know the standard deviation, we know we're using a z-test. Second scenario, two populations, we're looking looking at means with a standard deviation unknown, right? If it's unknown, we know we're using the t-distribution, so we're using a t-test, again, for independent samples. And then the third scenario would be when we have matched samples. So in this case, again, we're going to actually use the t-distribution. So those are the three that we're going to focus on how to do in Excel. Please also recognize that we still have population proportions that we can compare. That is using the z-test too. However, there's not really an easy default in Excel to do that. Other software programs there are. So I'm actually not going to really show you too much about this, but I do want you to be aware that it exists if you ever come across it in terms of, okay, like I could do it. A lot of what we learn about in this course in statistics, we're not learning everything. It's impossible to learn every different analytical tool. So a lot of times we're not going to go over every little detail, but at least if you're aware of it, you know it exists, and you know, oh, I could go back to the book to see how this is done if necessary. So overall, that's the overview of the chapter and what we're going to be focusing on.